Hi, this is Project Team 184, and we would be presenting our topic, which is non-photosynthetic vegetation soil cover percentage estimation using remote sensing data and neural networks. So, our basic overview of a problem statement is that we want to cover like dead plant material, which is the soil coverage, which can help in tillage conservation. The current process that we have at hand is time consuming, labor intensive, and lacks stability. It is like a method of physical survey which is redundant. So we want to improve it. We want to remove these things from this process and make it better. So our basic methodology is to take the cropland area, the farmlands area from the Delmarva Peninsula, and we want to map and quantify the amount and distribution of crop residue coverage in these areas. So we use satellite data for this. Our reference study is by Hively, which where they use the satellite data from Worldview 3 satellite and use these ground pictures to estimate the soil residue coverage there. They use XGBoost for it, and their accuracy range from 75% to 99%. This research paper will be our ground truth, and we will be comparing our results with this research paper. So the main difference between their study and our study is that they were using like a Worldview 3 satellite data, which has 4M resolution, and that thing is expensive. We are using Landsat Sentinel data, which is like an open source available data and has 30 meters resolution. Though the resolution is lesser, the cost is less, and we are trying to improve this thing. So we would also be reducing the cost that comes with this sort of prediction. Now, our methodology is to take all this satellite data as well as sensor data and to pre-process it. So we take all the satellite data, we process it, we get all the different bands, wavelengths from this thing and other sensor inputs, and then we take all this data and feed it to our models. Here we're using three models: random forest, neural networks, as well as extreme gradient boosting, and which was basically also present in our initial research paper. So we have a good comparison for our results, and our output will be a map snippet that shows the percentage soil cover in the Delmarva Peninsula region. So let's talk about a little bit about our data. The thing in our data is these are all the various features that we have in our data. As you can see, there's a strong correlation between NDTI and STI, also with res cover, which is our target variable, and these are very important. These are very important columns that help us in predicting these values. Moreover, we would be using a lot of these to predict our risk cover. Now, our preliminary results in with the XGBoost model, as you can see that the root mean squared error in the training data is low, but yeah, in the testing performance, this error increases. Similarly, the regression fits well here as we have a higher R squared value. Once we move forward, we have random forest there, which was sort of a baseline model for us, which we tested earlier. The root mean square error is low here as well in the training data, but yeah, it rises in the testing data, and the root mean squared error here as well fits considerably well in the training, but yeah, in testing it's lesser, which indicates overfitting. Then we have a neural networks model. Here we can see that yeah, the root mean squared error is low, and yeah, the R squared fits well here as well. But yeah, this was a baseline model. It just has one layer and four neurons, nothing more included in it, and it was very basic. So now proceeding further, what we did was on this data, we on this neural network we performed cross validation with the layers, the number of epochs, as well as the number of neurons that we had. So we got like the correct number of layers were 50. The number of neurons, the number of layers that the number of epochs were 50. The number of layers that we had, that worked best between 1, 2, 3, and 4 were 3, and the number of neurons in each layer were 16. So in each of the three layers was 16, and that gave us the best, score for it. And we used like the mean squared error only as our metric to check the score in this cross validation. Once we did this thing, we got a pretty low root mean squared error compared to all the other previous models. Also, we had like good training accuracy, the lesser error in training as well as lesser error in testing. Moreover, we could now also see that the R squared is high, closer to 1, which means that the regression fit pretty well. And yeah, this is a good model, and we tuned it, and this is what we are trying to achieve. This is what we were trying to achieve, and these are our results. Thank you. If you have any questions, feel free to email us and ask, I guess. Thank you.